Today we'll discuss with some more data types. Okay. First we'll see the hmm, uh, type def, type def data type. Okay. So type def data type. So type def means suppose like so we can create our own data type. Okay. Type def means we can create our own data type. Okay. Suppose let us take module TB, module TB. If I am writing A comma B and some piece of code, I am writing end module. Will you get any error in this? I am writing module TB A comma B end module. So what I am asking is, are you getting any error or it will execute this code? Why? Actually, we will get a error on. We will get error. So here we not declare the data type. No, we declare this as what variable. Okay. we, we not that means A is not defined. Actually this A whatever the A is there, this is not defined. Okay, actually in the place of A we need to have the data type. Okay, so like type def means suppose if I write if I'm using reg A. Okay, so reg A, here reg is what? Reg is data type and A is the variable. Okay, is the data type and A is the variable. So wherever I'm using that is A comma B, now A becomes what? So here I use type def. AE becomes reg. So I can make this is create my own data type. Okay. So this type def is used to create user defined data type, own data type, or we can create user defined data type. Did you understand? Okay. Okay, suppose here we can use so where we can use type def inside the module, inside the module, and we can use outside the module, outside the module, or we can use inside the class. Type def we can use inside the class. When we discuss oops, then we can see this type def, and we can use outside the class also, outside the class. Okay, so we'll see one example related to this type def. Okay, so you see this type def. Mm, yeah, opening the Vivado in this video playground. Here, uh, enum data type. So normally, like this is the example related to the enum data type, which will execute with the name and index. Okay, so like module TB, and I'm using type def enum idle s1 s2 s3 state underscore e. Okay, state underscore e means what? This total enum data type I initialize to state underscore e. So wherever in order to represent this enum in whole thing, I can use that is state underscore e equal e ps comma ns initial begin ps equal to idle. I want to display, that means I want to display the name of this enum, whatever the named constant, and wherever the index is there, I want to display. Okay, so I want to so dollar display the value of ps is percentages, and index is percentage d. So I will use a function called ps dot name and ps comma ps. Okay, so here I used type def only. Okay, type def inside the module. Okay, so if I execute this, so copy this and see in the PDF playground and run this code. So what I am getting, the value of PS is idle and index is 0. Is it fine? So this is one example, and one more example. This is Typedef inside the module. Okay, so this is Typedef inside the module. So here if you see module Typedef inside the module. So Typedef enum. So I am declaring the named constants idle s1, s2, s3 and enum underscore data. So wherever I am using enum underscore data, so that is allocated to what this enum idle s1, s2, s3. Okay. So here I am using enum underscore data ps comma ns initial begin ps equal to what idle. Okay. So same thing. So I want to display the name and this thing. So just to copy this and here you see in the EDA playground and run this code. So I'll get this one. So I will get the value of PS is idle and its numeric value is 0. Okay. So this is about the enum data type. Okay. Is it fine? So this is user defined data type. I can make means my own data type. Okay. Type def is I can make my own data type. Okay. Uh, so suppose so that means here there are like uh, three modules are there. Suppose module A and module B and module C. Okay. So here I am declaring this idle S1, S2, and here also I am using idle S1, S2, and here also I am using idle S1, S2. Okay. So here if I am using like type def, enum, uh, idle s1, s2, and enum underscore data. Okay, enum underscore data. So here, so I can use enum underscore data in any module. Okay, so I can use whatever this enum underscore data is there, no? So enum underscore data. So in any of the module, any module. Okay, this is the advantage. Okay, so I am using. Not like that. Suppose we can use like Typedef. Previously, I told you no. So suppose Typedef, if I am using reg a comma b, if I am using. So wherever I am using a, this is related to which data type? Reg data type. Okay. So suppose logic, if I am using logic a comma b. Okay. Typedef logic a comma b means wherever I am using a, in place of logic a, I am using what a. In place of A is logic, I'm using what A. A means what logic. So that is a user defined data type. Okay. So this is about the your type def. Okay. Type def means what? So we can make our own data type, and that is also called as user defined data type. Okay. So next is structured data type. Structured data type. So structured data type, if you take, so we already seen the arrays in the Verilog. No, what is arrays? Yeah. Arrays, actually, arrays is a, yeah, we can indicate the size after the variable. So this is collection of variables, no? Collection of variables. Arrays is what? Collection of variables of same data, of the same data type. Same data type. Okay, collection of variable with same data type organized in a single name and access using indices. Okay, organized, organized using single name organized using single name and access how we are accessing the arrays so accessing using index okay so we already seen like reg A 1 down to 0. Okay. Size is represented after this. So that means here, so in the arrays, so two locations will be formed. This is 0th location, first location. So this arrays we already discussed in the Verilog. Okay. Now structures. Structure. Okay. So what are the structures? Structures means we can store the data type, data at different data type. Okay. We can store, we can store the data. We can store the data at different data type. Different data type. Okay. Data at different data type. Okay. So the syntax is like this. Suppose syntax is we need to use a keyword called struct. Struct bit bit 7 down to 0 address. Bit 7 down to 0 address, and I'm using logic 3 down to 0 data data comma reg b. Reg b. So I'm allocating to what? Packed. Packed. Okay. So this is a packed data type. We already seen. This is packed data type means what? Packed data. Yeah, vector slicing is not possible. Okay. So we can means what we can do. We can combine the group of data type, different data types. So we can store as a structure. Okay. So we'll see with one example. Yeah, we combine the group of data types. Okay. So this is structured data type. One second. Yeah, structured data type. This is one example. So if you see this module structured data type, so what keyword I am using? Struct, packed bit 7 down to 0 data, logic 3 down to 0 address, bit A. I am using packed. Okay, this what is the data type? Packed. So I need to assign the values. No, how to assign the values means initial begin. Packet that data is 8 tick decimal 10. Packet that data is address is 4 tick decimal 20, and packet that A is 1 tick binary 1. Okay. So if I want to display the structure contents, so I use dollar display. The value in the structure are, so you need to use a format specifier percentage p comma packet. Okay. So like this we need to write. So just select all, copy this, and see in the EDA playground. So run this code. So I got the value of in the structure are, so tick in the concatenation like this I am getting concatenation data is 10, address 4, and A is 1. Is it fine? Okay. One more example. This is one more example. So I can use Typedef also. I can use Typedef in the structures. Okay. So Typedef. So I'm using a Typedef structure int ID in string name bit 7 down to 0 marks student underscore t. Okay. So that means here. So I told you no. We can declare the Typedef inside the module or outside the module. No. So this is a, yeah. This is the example we can declare outside the module. So module, so that means struct type def example. So that means structure variable declaration. How to declare student underscore ID is what? This is total structure. Okay. In case of this place of structure, this whole thing I can initialize student underscore t. What is my structure name? S1. Okay. Initial begin S1 dot ID is 101, S1 dot name is Sanath, and S1 dot marks is 85. I want to display this. Okay. So I want to display the student ID and the student name and marks. So dollar display all these things. If it is name means string, and ID and marks means percentage d end and end module. Is it fine? Okay. So just select all, copy, and see the EDA playground, and run this code. So here I am getting student ID is 101 and student name is Sanath and marks is 85. Like this I can execute. Okay. Is it fine? Okay, yeah. Next, we'll see about the strings. Okay, so we'll see about the strings. Uh, String data type. What is string? What is string? String is what? String. String is sequence of characters, no? String is what? Sequence of characters. Okay. Suppose if I use I will use a keyword called string. String I'll use str. Okay. What is the size of the string? What is the size? What is the size? No, actually, suppose if you are declaring like str equal to, you are using Verilog or system Verilog, okay? Or if you are using SV, okay? So that means here variable length, it will be dynamically increase allocated any character. Dynamically it is allocated. That means each character is 8 bit. So that is 2 into 8. So how many bits? 16 bits. 16 bits it allocated. Did you understand? Okay. So here if you see string examples. Sorry, close. So here suppose if I write module TB and string str and initial begin and str equal to I'll give system verilog. Okay, system verilog. Okay, system verilog and end module. Okay, if I want to display, okay, so I want to display, so that means dollar display I need to use. Okay, dollar display, the value of string is percentage s comma str. Okay, percentage, I want to see how many bits it will store. Okay, percentage d I will use. Okay, percentage d comma str. Okay, just run this code. Yeah. Mm, 1 second. So actually, like it will be stored in terms of 8 bits only. We'll see this code. 1 second. String, no? String declaration. Okay, this is the string declaration. So, so system verilog. Okay, so just I want to display this value. So just run this code. So name is what it will display, right? Like system verilog. It will display like system verilog. Name is system verilog. And next. Uh, String into int. If I want to uh, convert into int, so here I will use this is one example. So I want to convert string into int. So here I declared s equal to 123 int num initial begin. So num equal to this function I need to use. So select all, copy and see in the EDA playground. Run this code. So you converted your string into integer. Okay, string into integer. So this is one example. And next string iteration. Uh, so one more thing. Suppose if I want to convert the characters so if I give the capital letters, if I want to convert into small letters, okay. So how to convert means just if I am giving module TB, module TB, I'm declaring string str, and next one more string I'm declaring low underscore character, low underscore character, and next initial begin. Okay, str I'm giving as what str I'm giving as I'm giving low characters. Okay, that means so str equal to I'm giving capital letters. Okay, system Verilog. I want to convert this one into lower case. Okay, so how to write this low underscore character that is equal to, I'll use a function str to lower, okay, and I want to display the value of low underscore character is percentage s comma low underscore character. Okay, low underscore character end module. Okay, so just to save this and run this. So it is converted into lower character. Where I am getting $display the value of low underscore character is percentages low underscore character end module. Okay. Mm, okay, this I will check. Okay, yeah. Next is string concatenation. So string concatenation means if I want to means like string comparison also one more is there. So how to do the string comparison? Like if you see module string comparison, so I'm comparing. So string A equal to SV and B equal to small sv. Initial begin if A equal to B. Okay. $display string matches. Else $display string does not match. Okay. So just copy this and see in the playground. Run this code. So string does not match. Why? Because this is capital and this is small. So if you give both same means, so when you run this code, string will match. So string matches. Okay, this is string comparison. And next string concatenation. So string concatenation means what? So here you need to combine the strings. Module string concatenation. So first and last. That means full equal to first and last along with the space you want. Okay. So select all, copy, and see in the playground. So run this code. So here is given system and Verilog. First and last with space means system Verilog we are getting. Is it fine? Okay. So this is about the string operations. And next is one second. Next is casting. Okay. Next is casting. Okay. Casting. Okay. Um, this casting is also data type. Casting is nothing but like if you want to convert one data type to other data type, that we are using casting. Okay, so casting means what? So mostly in the system Verilog during the OOPS concept and also in the UVM we are using this casting. Okay, so casting means we are converting one data type one data type to another data type, another data type. Okay. So there are two types of castings are there. One is static casting. Static casting. Static casting means what? This will be done during the compile time. This will be done during the compile time. Compile time. And next you have dynamic casting. Dynamic casting will be done during the runtime. Will be done during runtime. Okay, if you want to convert one data type to other data type, then we are using the casting. Okay, we'll see the example related to the casting. With casting, without casting. Okay, see here. Suppose here I used see this one. So Typedef enum idle S1, S2, S3, S4, S5 state. So module without casting state PS comma minus initial begin PS equal to, I'm giving PS equal to what? 0. Okay. End and end module. Okay. So when I execute this, will it execute? Will it work? I'm giving PS equal to 0. Will it execute? Yes, yes, yeah. PS equal to idle. I'm giving PS equal to 0. I'm giving. So see here, it will not execute. Why? Because here not going to work because 0 is not declared. No, anyway. So here 0 is not declared. You are getting a compilation error at what 88 only. It's showing the assignment to enum variable from the expression of different type. Actually, these should be named constant, but here you given the value. No, you given the 0 value. Okay. So for this, what I can do means I will use state state tick. I will give 0. Okay, state tick 0. If I run this, now it will execute. Now it is executing. Suppose if I want to display dollar display, yeah, it's a syntax for the static casting. Okay, the value of the value of the value of PS is percentage s comma ps dot name. Run this code. The value of ps is what? Idle. I'm getting. Is it fine? Okay. And suppose if it is a so that means static casting will be executed during the compile time. Okay, whereas dynamic casting will be executed during the runtime. Okay, so how to display this dynamic casting? So this I'm just this I'm commenting. How to declare the dynamic casting is here. You need to use the dollar cast. Okay, dollar cast ps comma I will give 0 ps comma 0. Okay, so this is a static casting, and this is what? Dynamic casting. Dynamic casting. Okay, so just say this and run this code. So the value of ps is I. So this is the syntax. So this is the syntax for dynamic casting, where static casting is executed during the compile time and dynamic casting is executed during the runtime. Is it fine? Shall okay, yeah. So next, so this is about the casting we already seen. Okay. So first we seen the type def, and next we seen the casting, and next we seen the strings structures also with it. And next data type is arrays. Arrays. Okay. Arrays are classified into two types. Okay, so these are classified into two types. Those are one is packed arrays, packed arrays, and next one is unpacked arrays, packed arrays and unpacked arrays. Okay, so here, so first, so that means again, these are classified as static arrays, fixed arrays, and dynamic arrays. Okay, static arrays, static arrays, this static arrays and dynamic arrays. Okay, fixed arrays, static arrays. We'll discuss this. So, fixed arrays, and dynamic arrays. Actually, packed arrays we have in unpacked arrays. These are static arrays, fixed arrays, and dynamic arrays. In packed arrays, you have 1D array, 2D array, and 3D array. Okay, 3D array. So in pack, first we will discuss the packed arrays. Okay, so packed arrays. So packed arrays, we have 1D array, one dimensional array, and two-dimensional array, and next is three-dimensional array. Okay, 1D array, two-dimensional array, three-dimensional array. Okay, so first we will see the 1D array. 1D array. What is this 1D array? So 1D array actually, this is a actually the syntax is like this. Syntax is data type, data type, and size, and the variable name. Size and variable name. Okay. Suppose like reg 3 down to 0 array. 3 down to 0 array. Okay. Reg 1 down to 0 array. This is same as what we already discussed. Packed arrays. Yes, yes. That's what I'm asking. When we represent, yeah, when we represent the size before the variable, what is that? Vector. Yeah, it's same as vectors. Okay, it's same as 1D array in system Verilog is same as a vector only. Okay, so that means in packed array. So remember that in packed array, whatever the size is there. Okay, size is declared before the variable, before the variable. Okay, before the variable, and in unpacked array, in unpacked array, whatever the size is there, size is declared after the variable, after the variable. Okay, size is declared after the variable. Okay, suppose here if you take 1D packed array, 1D packed array. So how to declare? That means size is before the variable, no? So we need to declare like this. Size is before the variable 1 down to 0, comma a. Okay, this is 1D packed array. And if it is 1D unpacked array, 1D unpacked array. So how to declare? So size is declared outside the after the variable. So a 1 down to 0. Like this we declare. Is it fine? Okay. Suppose we are seeing the 1D packed array only. So 1D packed array. So when I declare reg 3 down to 0, a 3 down to 0, a. So how it will be actually how it will be stored? We already seen the vectors, no? So yeah, yeah, yeah. 4 bits are there. 0, 1, 2, 3. Okay. So vector slicing is possible. Slicing is possible. So slicing means what? We can access A 1 down to 0, or we can access A of 0, or we can access A 3 down to 1 also. It is possible. Is it fine? Okay. So we'll see one example related to this arrays, mm, packed arrays. Okay. So packed arrays if we see. So packed 1D array. Okay. Packed 1D array. This is the example. Module packed 1D array, bit 7 down to 0 data. Okay, bit 7 down to 0, initial begin, data equal to what? 8 tick binary 10101010, like this I am giving. Dollar display 1D packed array is percentage B comma EA comma data end and end module. Okay, so this is a 1D packed array. Just copy this code and see in the playground and run this code. Yeah, 1D packed array is how much? So 10101010. So this is 8 bits now. So 1 down to 0 comma data. So that is 10101010. So I am getting. This is 1D factor. So remember that 1D factor is same as the vectors in the Verilog. Is it fine? Shall I move forward? Okay. Next you have 2D packed array. 2D packed array. So 2D packed array, how you are declaring means, suppose reg 1 down to 0, 2 down to 0, uh, p underscore array underscore 2d. Okay. So actually this is a, number of dimensions. Number of dimensions. Number of dimensions, and this is width of each dimension. Width of each dimension. Width of each dimension. Okay, so that means here how it will be stored means, so total how many dimensions are there? So total you have two dimensions are there. Okay, this is the dimension. First we need to draw the dimension 0, dimension 1. Okay, so this is number of dimensions are 2, and each dimension we can accommodate how many bits? 3 bits. So this is 1, this is 0 1 2, and next this is 0, next 1, and this is 2D packed array. Did you understood this? 2D packed array. Okay, so we'll see one example related to this. Uh, so packed 2D array. One second, packed 2D packed array. Yeah. So this is 2D packed array. This is the example. Mm, so so module 2D packed array. So module underscore we need to give. Why? Because if you are giving number, it is will not, yeah. So reg 1 down to 0, 2 down to 0, p underscore array underscore 2d, initial begin, p underscore array underscore 2d is 8 tick binary, this value. Okay, this value, I want to access only what, this 0. Actually, if I want to access this, what is that? The 0. Okay, what is the output? Can you expect the output in the playground? If I see 101, yes, 101. So that means this lower dimension I am accessing. Okay, so lower dimension I am accessing. Okay, so suppose if I want to access whole dimension, just no need to use that dimension. So I am getting whole dimension. Okay, suppose if I want to like access the first dimension means here I will give what, 1. Okay, if I give first dimension, I will get which value? 001. Okay. So if I want to access the lower LSB bit, okay, how to give? 0 comma 0. Okay. So this value, only this value I want to access. So p underscore array underscore 2d 0 comma 0. Okay. So 0 comma 0 means I will get this. So the p underscore array is what? Only one value I'm getting. Do you understood? Is it fine? Yeah, yeah, yeah. Suppose one to 0 is there. Which value I will get? 1 to, suppose if I take 1 to 1, 1 to 1, which value I will get? 0. Yeah, this value I will get. 0 I will get. Okay. And one more example. This is actually like by using for loop we can use. So pit. So this is related to 2D packed array. I am declaring a bit 3 down to 0, 7 down to 0. Matrix, I am 10 locations I am declaring. Okay, this is a dynamic array. Okay, initial begin matrix equal to this value, and for in, so I want to declare like a matrix int for int I equal to 0, I less than 4, I plus plus. Okay, so I plus plus will work in the system Verilog. Okay, whereas in Verilog I plus plus will not work. I told you, no. So dollar display percentage d I comma matrix. Okay, it will execute in terms of matrix. Okay, just copy this and see in the playground and run this code. Yeah, it's not executing. Mm, okay, okay. I'll check this code. Okay. So this is about the different packed array, unpacked arrays, 1D packed array, 2D packed array, and 3D packed array we'll see in the next class.